So this shape describes the time to failure of something with a constant hazard rate, which means this thing never wears out, accumulates damage, or gets old. It also never wears in, meaning it has no defects, problems, or software bugs that cause early failure. The only type of failure this thing experiences is external and catastrophic failure like the ones we've just described. In practice, nothing has a consistently constant hazard rate. Products might have a constant hazard rate for a small part of their life, but they will still experience some wear in, or some wear out, or both. And some products never have a constant hazard rate for any part of their life. But lots of professors, engineers, and designers like to ignore this fact. So they often misuse this ultimate histogram shape to describe the random failure process for things like tyres and ball bearings that we know wear out, and things like small satellites that we know wear in. None of these products or systems have a constant hazard rate. So why do people like to pretend they do? The reason is that it makes everything simple, or more correctly, too simple. If we assume something has a constant hazard rate, then the mean time to failure is the only thing we need to define how far spread out this curve is, because its overall shape never changes. So you only need a single number to describe the failure process of something, as long as you assume it never wears in and never gets old. This simplicity is very attractive, so hundreds of textbooks, standards, and guides pretend that you only need to define the MTTF or MTBF of something to understand its probability density curve. And therefore, it's the only metric you need to describe reliability. Assuming a constant hazard rate like this creates huge problems when we're analysing component or product reliability. But things get even worse when we look at the reliability of systems with multiple components.